Hello, everyone. I
Hey
hope you
everyone.
well. Hope you can hear me well. If anything happens with uh, that you cannot hear me, just let me know. Um, let's wait 2, 3 more minutes for the other people to join, and then we will start our presentation. David, if you could already put the slides up, just so we have it covered, I appreciate. Thank you very much. I think 1, 2 more minutes and we can start. Thanks for the patience, guys. Yeah, just so everyone knows, this call is being recorded. The goal is that we will have this as a resource that the Olas community can use in the future. So I hope you guys don't mind. There is someone trying to join the call, but I can't see it. Since everyone is here. Okay, should we start, David? Welcome everyone for the here in the Olas Dev Kickstart. If you can move the slides, please, for the next one. Yeah, next one. So what we are going to cover today is very briefly who we are, what is the goal of this Dev Kickstart sessions, very brief intro to Olas, what is autonomous agents, use cases, service architecture, and then the most important part that is build your own Mech tool. This is going to be where we are going to focus most of the time. So a little bit about me. David, can you go ahead, please? So I am a product manager here in Valerie, one of the core contributors to Olas. And I am also, before I've been in Web3 for the past 3 years, more or less. Before that, I worked for Facebook as a program manager and as a content strategist for Google. And in another life, I was a lawyer. Just a brief disclaimer before we go ahead, just otherwise I need to comply to all the legal things here, is that this material and this session is being provided by Valerie for the Olas community. So it's not intended to be financial advice in any means. And it's also, Valerie is not talking on behalf of the community. So now that I took this, I complied with this legal thing, let's move forward. David, if you want to talk a little bit about yourself.
Yeah, that's me. Hello, everyone. I am David B., one of the software engineers working for Valerie for almost 3 years now. I'm also one of the founding members of Olas. And my background was originally on mechanical engineer, but yeah, at some point I recycled myself into software engineer, and here's where I ended. And today I will be showing you guys how to create your own Mech tools. And yeah, we will talk about that in a second. But first, I think Caroline wants to say something else, something more.
Yeah, just before David goes into the intro of Olas, I just want to highlight what is the goal of the Dev Kickstart sessions. So this is just the first one, and the idea is to make it very easier for devs to contribute code to Olas for the chance of start earning dev rewards. As soon as you contribute something valuable, you are then eligible to receive the donations and then receive the dev reward. So that's our goal here. Yeah, you can go ahead, David. Thanks.
All right. Thank you, Caroline. So, yeah, I guess for most of you, you have already heard of Olas and what it is, but maybe that's not the case for everyone. So I would like to spend like the first 5 minutes or so talking about, well, making a small intro to what is Olas at high level. So Olas is, we usually like to think of it as a three-legged stool. Olas is a protocol, it is a stack, and also an ecosystem for creating autonomous agents. We will define in a second what an autonomous agent is, but you need to be aware that there's three parts to it. So we have this on-chain protocol, like a set of rules about how agents interact and create value. There is an open source stack, basically a framework, a software framework to create this kind of agents. And of course, all the agents that are out there deployed and creating value that form this rich ecosystem. So this is why we usually say that there's like the three sides to Olas. So some people might be asking what an autonomous agent is. And especially during the last times, we are hearing about agents a lot. Everyone has a slightly different approach to what an agent is. But in our case, when we talk about a Olas agent, we like to define that as software entities that run continuously, that can take action on their own, and that they run off-chain while being on-chain crypto native. What does it mean? So basically, agents are like pieces of software that run off-chain, but can interact with not only off-chain entities like traditional Web2 APIs and so on, or databases, but also can create transactions, make contract calls, and so on. And we think this is a very powerful and flexible approach, because if you have a look at this drawing on the top right of my screen, we usually have either traditional web services, which are very flexible and, let's say, kind of intelligent. We also have smart contracts, which are flexible and crypto native. And more recently, we had these oracles and this kind of automation that are also crypto native and intelligent, but not so flexible. So we would like to think that autonomous agents and autonomous services are getting the best of the three worlds. So as you can see here, basically what I just said, basically any agent or any agent service, we will talk about that in a second as well, but can interact with both on-chain and off-chain world. Anyone can create connectors and pieces to basically connect to everything. So what can we do with this? So there's multiple different configurations that we can use to run agents. For example, if you are a single dev and you are interested in running your own single agent, we usually call that a sovereign agent. So this is a lightweight agent that you can run at home, either in your laptop, your server, on the cloud, whatever. It's just one agent. It's completely centralized, but it's very flexible and lightweight. Sometimes that's not enough. Some companies or some people might be interested in running these agents in a decentralized fashion for the purpose of transparency and robustness. So these sovereign agents can be turned into decentralized agents with basically a couple of lines of configuration changes. So let's say at some point you are running your single agent, then you have some friends or some members of your company interested in running this in a decentralized way. So all of you can basically run the same agent, and through the Olas protocol, all these agents can connect to each other and make decisions in consensus. And this, of course, creates a very powerful primitive where agents can consume other agents' services and provide services to other colleagues, which lets us create these rich agent economies where basically agents behave as almost as we humans do, like consuming services, providing services, and producing value. So when I just mentioned this decentralized agent thing, I will like just, you don't need to know this for today's workshop, but it's important that everyone has a high level overview or what an agent looks like. So when we have these two different kind of configurations, we have a layer on top of this, which we call service. When we say agent service, it means basically an agent that can be configured as running as a single agent or decentralized agent. You modify the configuration, you run with 1, 4, or 40 different agents. So this is what we are showing here in this slide. Basically, an agent service is this concept of at least 1, but up to n different people operating an agent. So let's say here we have n operators running n agents, and inside each of these agents, we have the business logic that implements this application. This is what we call the FSM app. More on that on the coming sessions, but basically all these agents running their logic use what we call a consensus gadget node, which is currently Tendermint, to connect to all the other agents and make decisions in consensus. So that's why we have this purple box here. We like to think that the agent service is an entity that englobes all these agents. If one agent dies or 2 agents die, there's no problem. All the rest of the agents can keep running. We always require that 2/3 of the network is up and running. And basically, this means that we have a high fault tolerance. And as said, these agents are connected to the internet and can interact with multiple blockchains, but also with traditional APIs, databases, and expose their own APIs to end users and so on. So using these primitives, we've been creating this ecosystem of different services which interact with Ethereum, but also with protocols like Ceramic, IPFS, Web2 APIs like Twitter, and other chains. Olas is currently deployed on 8 different blockchains, and therefore we can basically interact with a lot of not only chains but also traditional services. So this means that for the last, I think since last summer or so, these agents have been minted. I mean, when I say minted, I mean people have been creating this kind of services. We now have more than 467 services minted on the different chains where Olas is deployed to, that have been producing more than 700,000 transactions across Ethereum, Gnosis, and all the other chains. So it looks pretty good. All this ecosystem is growing by the day, and therefore we are very interested in having people like you guys building your own services. But since building a services takes more time, we thought that we should focus on this session on helping you to first understand the simplest use case, which is the Mech tools. And I will now explain what a Mech is and what a Mech tool is. And for that, I'm going to go to this repository we have prepared for you. This will serve as template for this session, but you will be able to download it or fork it and work on top of it.
David, apologies to interrupt, but there is a question here, and the Peanut asks, what means consensus gadget node, and why it's important to have a consensus?
Yeah, so let me go back to that.
Quickly. if it's quickly for
Yeah.
you to.
So this will be covered. On higher level, basically means that when we create each agent, we do it in a slightly different way of when you think of a traditional, I don't know, Python script. When you create an Ola service, you usually need to design it in a way that you completely separate the application in multiple steps. For example, if you are, I don't know, coding a trader agent, we can say that on an architectural level, you first need to, the first step on the execution of this agent would be, for example, to check the price of some crypto token or whatever, then to evaluate some trading strategy using that price that it gathered from some API, and then you need to execute a transaction. Let's say that. So we have three main different steps, right, for our application. When I talk about consensus, when we are running in a decentralized manner like these decentralized agents, it means that after the first step has been executed, so all the agents have retrieved the price from, I don't know, CoinGecko or CoinMarketCap or whatever, then all the agents will send messages to all their peers and will vote on what the most popular price. For example, if we have four agents check the price and find that the price of Bitcoin is, I don't know, 70K. So they send messages across this consensus gadget to each other. And once they agree that the price is that exactly and not other, then they go into the next step, which would be run the trading strategy. This strategy step is run by all agents. They also produce some output data at the end of this step. And once again, they share all their data with all their peers. They vote. And once they agree, or at least once the majority of them agree on some output, they go into the next step, which is producing the transaction. Once they have agreed that they are going to make some trade, some transaction, then when we run like this, all services, all the agents control a Gnosis safe, which is basically a multi-sig wallet. This means that they can only trade, they can only make transactions or make contract calls if 2/3 of the agents agree on that transaction. So you cannot have like a rogue agent that moves funds. When you run like this, if you have 4 different agents, 3 of them need to agree on the transaction and sign it before the transaction can be settled. That's what I mean by consensus. They are asynchronous messages, but they are not, we have some timeout, so there's like a time window where agents wait for the other agents to send their messages before they start the voting. Does that answer your question, Peanuts? I will take that as a yes. And I think we can go now to, well, because Caroline, this is for the end, right? This slide is for the end. Or are we taking questions now?
No, this is after you show everything on the GitHub template, and then if they have some time for Q&A,
Perfect.
hopefully. Mm-hmm.
Now we have this repository, which is the Mech tool template. So first, we need to understand what the Mech is. I told you that we have a lot of different services. One of them, and one of the most popular of these services that provide services for other agents is the Mech. The Mech is one agent that can be thought as an on-demand brain for your applications. So let's say, for example, that you are creating an application, another service, or even some Python script, or you are only focused on front-end, and you want to make a call to OpenAI API or Stability AI, basically any API. We usually focus on LLMs, but there's no limit on that. So you certainly don't want to pay for different APIs, at least in most of the cases. So the Mech basically is like a library where you can use what we call tools to do this. So you send a request to the Mech, and the Mech acts like a proxy and makes some requests for you. So you pay for one request, something symbolic like 1 cent, and then you can make a request to OpenAI or Stability AI or whatever. So basically, the Mech is listening always for on-chain requests. This is the important part. These requests are made on-chain. We have this service deployed to multiple chains, although the most popular chain at the moment is Gnosis chain for these Mechs. And basically, this is how it works. Once again, this is not, you don't need to know this, but it's important just that we start thinking on how these things work. So let's say you have one application and you want to make a request to OpenAI API, right? So the first thing you should do, I mean, this is all completely abstracted away. You won't need to code this, but it's important that you know at high level how it works. Basically, your application must create some request, which is a JSON object that is written to IPFS. Then, in exchange, you get back I don't know if this is visible enough. Let me zoom in. So once you have written your request to IPFS, you get a hash, a data hash, and then you send a transaction. You make a contract call to the Mech contract. This is deployed on several chains. We will focus on Gnosis chain today. So you write that request hash to the Mech contract, and then we have the Mech service, which is always listening for contract events. At some point, this Mech will read your request hash, and then it will realize it needs to go to IPFS and tell IPFS, all right, I have this hash, please give me the request metadata. IPFS will send the metadata back, and now the Mech is seeing what you are looking for. Your request might look something like, I want to make a call to OpenAI, I would like to use ChatGPT 4.0, and I would like you to use this prompt. So the Mech has a lot of different libraries. Will realize that you are trying to use OpenAI tool, so it will dynamically load this tool and will use this tool to forward your request into OpenAI API. We'll get the response back, and the same process is done again on the reverse. Basically, we write the response to IPFS, we get the hash, and then we write the hash response to the Mech contract, where your application will be listening. At some point, it will get a chain event, will read the response, and will go to IPFS with that hash. And finally, the application gets the response, the complete response. This means that this process can take sometimes from a few seconds to a couple of minutes, depending on how loaded the Mech is, because all this request is going through the chain both ways. All right, so let's have a look at how how a Mech tool looks like. When you are trying to use this repository, you will need to fork it and install Python at least 3.10, pip, and Poetry. Here you have some useful links for the installation of those requirements. And what I'm going to do now is I'm going to bring my terminal here. Yeah, there's some question here.
Yep, there's a couple of questions in the chat, maybe.
Let me check. So, not sure if I understand the question. Do we need to create the JSON message with the API key? Well, the thing is that you don't need any API key, because that's the point, the complete point of the Mech. If you are using OpenAI or any other API, traditionally you need an API key, right? But you don't want to have like multiple API keys if you want to use multiple APIs. So the idea with the Mech is that you just pay for this transaction, when you write your request here to the Mech contract, you also put something like 1 cent of a dollar to pay for that service, and then the Mech serves your request back, but you don't need any API key. Everything is done basically through your wallet. The other question is Mech library is I don't think I understand the second question either. Sorry about that. I guess you are referring to how to communicate with the Mech, or well, for that we have both what we call a skill for agents, but we also have a library so anyone can use it. And I will demonstrate this in the coming minutes. Basically, there's two ways of doing this. If you are if you're making a Mech request for your agent, there's some code already there. But if you are doing from a Python script, and I will do in a second, we also have a library for that. So yeah, give me a few minutes and I will demonstrate it. I'm now going to, as I said, bring my terminal here. And the first thing I want to do is to create a fork. I'm going to clone basically this repository. I'm going to, for example, get this. I'm going to get this repo. You can also download the repo there we go. Now I have this repo here. The first thing I want to do is to prepare a virtual environment with Poetry Shell. And I'm going to install all the dependencies with Poetry install. This should install everything that's needed to run the examples. And first of all, I'm going to show you what a Mech tool looks like. And for that, I have prepared two different tools. A dummy tool that is like a calculator, and then a more serious one that actually makes an OpenAI request. So let's say that for some reason, I think it's a good idea to have a calculator as a Mech tool. So I would like to send requests like asking the Mech, I have these two numbers and I want to add these numbers, right? So first, as basically you can see, this is a normal Python script. I have two very basic functions, add and multiply, that basically add numbers and multiply numbers. Then I put all these two different functions in a dictionary. This will be my set of tools, right? I call it available tools. And then the only thing you need to take care is, this is the most important line on this script. Basically, any Mech tool needs to conform to this, it needs to implement the round function. And this is a function that is expected to receive some quarks and always returns a tuple of 4 different objects. Basically, the first one is the response. The second and third and fourth one are completely optional, but we are expected to return the prompt there if this tool uses a prompt. And then there's other not important objects here. For example, if some tools create some transactions, which is not, I mean, we won't cover this today. That's not important, but these are related to this kind of thing. We will only focus on returning the correct response. So we implement this round function, and in this quarks, we are expected, at least I am expecting this tool to receive something called a tool, which will be the name of which of these two functions I want to use, either add or multiply. So I get the tool name, and if for some reason the user does not send the tool, then I will set tool name as none by default, so I can basically detect this error and return error response. Error response, you can see that this is this mini function here that just returns an error message and then sets everything to none. So here, in this case, if the user has not set the tool, you will receive a response that says no tool has been specified. Then we basically, using the tool name, get the tool from the available tools dictionary. So in the end, this tool variable will contain either the add method or the multiply method. So my tool is here now. I once again check that the tool is not none. If it's none, I return an error. And then I also get from the quarks the first number and the second number. And I check that they are integers or floats, because if not, we cannot add or multiply those. If you have been paying attention, you have realized that basically all this code that I have been explaining is basically some stupid code to just check that everything is in place, that the user has not made any mistakes. But the actual tool run is this single line where I basically call the function, I pass the first number and second number, I calculate the response, and then I send the response back, setting a string for the response and all the rest of the objects to none. And then I have added this if name main, so that we can basically run this as a normal Python script, which I am going to do right now. So if I go into packages, well, another thing that I should have mentioned is that whenever we implement tools, maybe it's easier if I show you here in the repository. Tools, every tool lives in a different folder. Whenever you go into the packages folder at the root of the repo, you will find here at least one name. This is basically the name of the author. If your name is John, you will create here another folder called John. If your name is Mary, same thing. We are coding this as Valerie, so I created a Valerie folder. Then you will need to create the customs folder. This is the name of the folder that contains Mech tools. And now here you put all your tools. We are now talking about calculator requests. So we have this folder that includes this Python script that we have been seeing, and also some other file that I will explain in a second, which is basically some configuration file. So let's go back to our little script and terminal. Let me open the, well, anyway, basically, as I told you, this is in Valerie, customs, and the calculator request. The script is called calculator request.py. And when I run it, basically, I am adding 17 plus 5, so I get 22. Keep in mind that this is always a string, so if you are expecting some number, you will need to process this. So this is, up to now, it's a very simple Python script, right? And then let's then see the other example, unless there are any other questions. I think there's another question. Why is there the init py inside the Valerie folder? Is that necessary? Oh, yeah. So basically, yes. It's always good practice to have this kind of init in order to import. I mean, it will most certainly it will work anyway. But for good practice, we usually add some empty init.py file at all the folders level. You can see that there's another one here and also one inside each folder. So yeah, add one of those as well. Let's have a look now at the second of the tools, which is the prediction request. So most of the tools that we are running inside our Mechs are related to predictions. And why is that? Because a lot of people are running trader agents. And this means that there are a lot of agents that are trying to make bets and trades on prediction markets. And for that, they basically want to know what's the probability of a future event happening. For example, what's the probability of ChatGPT 5 being unveiled before June, something like that. And of course, no one knows the actual answer, but we can create tools that parse the news or parse the sentiment on Twitter or whatever, and use LLMs to try to make a prediction. And this is basically what I have coded here in a very, very simple fashion. This is a very stupid tool. We have more complete tools on the actual Mech repository, but I have created this tool where we just make an LLM call to OpenAI, and we use a prompt like this. Basically, we are saying, you are an LLM inside a multi-agent system, blah, blah, blah. You take a question for a user, and you need to answer with either Y or M if you think this is going to happen or not. And I am expecting you to send back, to respond with a JSON object that only and only contains the response and that letter. Okay, this is a very simple prompt. It won't be very useful because, of course, the LLM does not have access to external data sources. For that, we would need to create a more complete prediction tool, like the one that we are running on the actual deployed Mech. But for academic purposes, we will keep it simple. We now have this class, which is basically a manager for the OpenAI client. We could do the same thing for other APIs, but I focused strictly on OpenAI here. This is not something that you need to know about. Basically, you can copy paste it if you want something similar, but you can see that basically this is a class that uses the API key to instantiate the OpenAI client and make LLM requests. So we implement the enter and the exit methods because this can be used as a context manager, as we will see in a second. Then there are some default values, like, for example, what are the maximum amount of tokens we want to spend, what's the default temperature, which engines are we supporting, meaning which versions of ChatGPT. In this case, we are supporting GPT 3.5 and GPT-4. And then once again, we have this function that is the common thing across all the different Mech tools. Remember that you always need to return a tuple with 4 different things. The last 3 things can be none, but the response should be the first one. And here's where we use the OpenAI context manager. Basically, same thing again. We get some default, some parameters from the user. If the user has not set those parameters, we have some default values. So we have here the max tokens, temperature. Here we get the prompt, the tool, as we did in the previous example, and some other things that are not important for this example. And then, once again, we check that everything is correct. If your tool is allowed, if the tool is not allowed, just return an error, and so on. Once we have all the parameters, we have instantiated our OpenAI object. Then it's a matter of calling the LLM in the same fashion as we did in the other example with the calculator method, right? So there's 2 different calls here because different versions of ChatGPT have slightly different interfaces. But basically, you can see that here we are just making a call to this client library where we pass the model, the messages, the temperature. When I say messages, I mean the prompts, because we are creating here this list of messages where you basically are telling the LLM that it is a helpful assistant, and then we basically send the user prompt. Once we make the call, we get the response, and we send it back to the user, similarly to how we did on the other example. And once again, I'm going to run this first as a normal script, for which I need to export. These instructions are on the README. When you go to the repository, you will see that you will first need to export your OpenAI API key if you want to run this locally. Once again, this is only needed for local testing. Once this is deployed to a Mech, you don't need any key. So first, for privacy, let me export. I will run this command in other screens so you cannot see my private key. A second, let me copy the key. There we go, and I'm back. And now I should be able to basically run this script. It's waiting. There you go. So what I have run basically is I have asked OpenAI, will autonomous agents rule the world someday? And it seems that ChatGPT 3.5 Turbo thinks that no, that won't be the case. So I think we can be safer now. And yeah, this is how we run the simple examples locally. And now I am going to show you how to interact with an actual deployed tools. The idea is that you use this as a template. You implement here your own tool, or you modify these two tools that we have in this template. You can have some crazy ideas to implement. And then once you have your tool, you can create a pull request on the Mech repository and tag one of the engineers for review. This is something that I have also added at the end of the README. Basically, whenever you make some changes, for example, I don't know, I could be changing my my question to just changing a word here. You will always need to run this command. Again, this is on the instructions, but basically this means that you calculate when oops, sorry. I'm missing a net. This command means basically calculate the hashes of my tools. This means basically that all the tools that we create on the Olas stack are hashed and are identified by an IPFS hash. So when you run autonomy packages log, these hashes will be automatically calculated for you, and you can check the hashes on the packages folder, packages.json. This is the hash of the calculator request tool, and this is the hash of the prediction request tool. Anytime you make any change to your files, this should change, even if it's a single dot or a single space. And once you have that, the next thing you want to do is to do this. Autonomy push all. This means that you are pushing your tools to IPFS. At this point, these tools now live on an IPFS node, and you could open a pull request on the Mech repository and tag one of the engineers. There's a link here at the bottom. When you go there, you will see a list of engineers who contribute regularly to the Mech. Here, this is me, this is Arjan. Arjan is usually the one who manages this, but you can tag one of these engineers and we will review. Once your tool is approved, it will be merged and deployed to the Mech. Of course, anyone can run their own Mechs at home, but it's a kind of tricky. So we usually recommend new developers to first try to just develop and focus on the Mech tool and deploy it to the Mech that is already out there. Yeah, let's go now to how to interact with an already deployed Mech tool. So let's say that you have opened your PR, it has been approved, it has been merged and deployed to the Mech. And now you are creating an application and you want to send a request to that Mech tool. First thing you need is a wallet with at least a few cents to pay for the requests. So either you export your private key from MetaMask or similar software, or you create a new key. I'm going to create a new key using this command here, AEA generate key Ethereum. So I'm going to go here, run this, and I will show you this private key because this is a dummy thing. So when you run this, a new file should appear on your repository, which is called Ethereum private key.txt that only contains the private key to your wallet. You should never never show this to anyone, and that basically, yeah, should be private. You should not push this to your PR and so on. All right. And then what I'm going to do is I'm going to get another private key that has already some funds in it. 1 second. This one has some funds in it to pay for the transaction. I'm going to paste and replace my previous key. There we go. And first there's two different ways of using the Mech Interact client. Basically, first one is using it as a CLI interface. It goes like this: Mechs interact. You set a prompt here, like write a short poem. There's a number here, which means the Mech ID. So we have different Mechs deployed to different chains. Each one of those is identified with a number. The Gnosis chain one is number 6. But if you go to the Mech repo, you will see a table there with all the Mechs and all the identifiers. I am now also setting here which file contains my private key and which tool I want to use, as well as that I would like this transaction to go into the Gnosis chain, and the confirmation of the response should also happen on chain. This means that there's different ways of getting your response back once it's from the chain, but also we can do it using a subgraph. But using a subgraph means that we need a WebSockets RPC, so this way is easier. So I run this, and some things are going to happen now. First, you can see that it says sending request and prompt uploaded. We have a link here. I'm going to click it, and this brings me to Valerie's gateway to IPFS, which means this is the file, this is the JSON object that has been uploaded to IPFS. So you can see that there's a prompt with write short poem text here. It also contains a tool, and then has a unique identifier, a nonce, that basically means that this request will be unique, and this will be used to identify both the request and the response. Now, we have another line that says that a transaction has been sent. So if I click here, we are redirected to Gnosis chain, and we see that we have a transaction success here. This is my transaction hash, and when I go to the logs, you can see that there's some request chain event emitted, and at this point, the Mech that is listening to this contract should have received this request, and at this point should be analyzing this, getting the request from IPFS, sending it to the OpenAI API, getting the response back, and writing the response to the chain. Finally, we get the ID confirmation, and we are now waiting for the Mech response. For some reason, it's taking longer than usual. This, as I told you before, is usually around 20 seconds, 30 seconds in average. But if for some reason a lot of people is under request, this could be delayed for a couple of minutes, 3 minutes. So let's give it 1 more minute. And in the meantime, I can show you how to do the same from a Python script. This was using the CLA, but we also have a Mech request. This is how we do it from a Python script. So, oops, sorry, there we go. If you want to make a Mech request to your tool using Python, you basically only need to import a couple of classes and functions from the Mech client. Then once again, you need to set all the data that you use on the previous example, like the prompt text, agent ID, a tool name, a chain config, which means which chain are we using, in this case Gnosis, and also the name of the file that contains the private key to the wallet. And the only thing you need to do is call interact. you call interact passing all these parameters, and basically that's it. The process is the same. You can run this script. Let me open another terminal. I need to activate the shell. And now I'm going to run Python script Mech request. When I run this, you basically see something very similar to what we saw in the other example. We send the request, the prompt is uploaded to IPFS, the transaction is sent, and once again, we wait for the transaction receipt. The transaction has been succeeded now, so we now wait for the Mech response. Yeah, this is taking too long. Might be some issues. Sometimes we also face some RPC issues or some Mech issues, but I don't know if this is the case today. I will continue explaining a couple of other things and we'll come back to this in a second. There we go. Let's go to the repo. So let's recap a bit. We have been talking about what a tool, a Mech is, what a Mech tool is, what the request response flow looks like, and we have seen that this repo contains two different dummy tools, one for calculating numbers, one for making simple requests to OpenAI. And then we have also used both the Mech CLA for interacting from the terminal, but also from a Python script. And once you have done this, like you have created your own tool, your tool has been merged, you have tested it, it's time to try to get some dev rewards from your nice work. So the way to do this is basically you need to mint an NFT that proves that you are the owner of that piece of code, that this Mech tool is yours, and for that you need to mint it on the Olas protocol. To do this, we have the protocol frontend, which basically, well, a part of the protocol frontend, which is basically the registry. The registry is a place where you can see all the components, all the agents, and all the service that someone has minted at some point. And whenever you are ready to mint your component, remember that this command I ran before, which was autonomy push all, and you got these hashes. You will need this in order to mint your component. So let's copy this hash because I will need it in a second. And let's say I want to mint my own component. So I will go here into components and I will click on mint. Here, you need to connect your wallet. Mine is already connected, but let me get my wallet address. I will set the owner address as my own wallet. And now we need to create some metadata file. We click on generate hash on file, and we are asked about some metadata. For example, what's the name of this Mech tool? For me, is my awesome Mech tool. And for description, I will set this as this tool is awesome. You can use whatever version you want. The important part here, that do you remember this other file that we mentioned, but we have not explained yet? Every Mech tool has a component.yaml file which contains the name of the tool, the name of the author, the version string, and then some description. All the rest of the things are calculated automatically for you, with the exception of the dependencies. If your tool has dependencies, you also need to list them here. For example, for a tool like the calculator, you can see that the dependencies is empty, and this file is very, very easy. When you run autonomy packages lock, all these fingerprints, all these files, everything is calculated for you. You only need to take care of the name, the author, the version, and the description. So my tool is version 0.1.0. So this is what I put here. And now I am asked about my package hash, which is the thing I copied from here. So there's two different package hash versions that we can use here. We will focus on the one that starts with BAFY, so and so on. And if I paste here, you can see that my hash already contains this Buffy part at the beginning, so I'm going to remove it. And last thing, optionally, is that whenever you build your own component, you can set a nice image for your NFT. So here I have one image prepared and pushed to IPFS as well. This is the hash. This thing that starts with QM is the hash of this image. So I'm going to paste here and add IPFS at the beginning. This means this is an image that is living on IPFS, and this is the hash. And now click on Save File and Generate Hash. And some magic happens, and some hash is calculated for you and added here. Then dependencies do not matter for us. This is for other kind of components that are not Mech tools. This will be empty for us. Once you basically are finishing this, you click on Submit, and you are prompted to sign a transaction. I'm not going to mint today this, but basically the only thing that remains to be done here is once you click Submit, if you are using MetaMask, for example, you are asked to pay the minting price. And once the transaction goes through, then you will receive an NFT on your wallet that proves that this component is yours. At some point, if someone finds this component useful and includes it as a dependency of a service, for example, Valor's Mech, you could receive some dev rewards when people make donations to the services that use your tools. Let me check if for some reason there's some I think we have some issues today with the Mech. I will need to check with the other engineers, but yeah, since we are almost running out of time, what we should be seeing here once the request is responded is that we should see the same response that we saw when we ran this locally. We should be receiving here a JSON object, including the response and 3 different non-objects at the end. And if I am not mistaken, that's pretty much it. Be aware that your PR should be submitted to the Mech repository, not the Mech tool template. The Mech tool template is just meant, this is the repo I have been showing. This is just meant for testing, for running things locally. Once you have everything prepared, you should open your PR against the actual Mech, which is inside the Valerie -XYZ handle. And yeah, that's pretty much it. Let me go back to the presentation and check whether we have some questions.
Yeah, we do have some questions here in the chat. Do you want me to read for you, or do you want to read yourself?
Yeah, why not?
Okay, 1 second. The first question. Why is there the underline init underline PI inside the Valerie folder? Is that necessary?
I think I already answered this one. Yeah, we need that one. Just, I mean, it's usually when we import modules from Python for this specific purpose. I am not sure it's completely necessary, but we do that because at some point we want to import modules and code from other folders. So yeah, that's good practice. And then the other one is, yeah.
Do you want me? Okay. Yancy asked, so the Mech essentially extracts the answers from external LLMs. When there are multiple LLMs available, will the Mech ask all of them and get consensus, or the Mech will decide on which model's answers to return?
Yeah, so basically the Mech tools are not restricted to which kind of work can do. we can have a simple tool that just make a call to OpenAI, but maybe another tool makes a call to Stability AI. If you need a tool that makes a call to all of them, or maybe you are interested in doing something that does not call an LLM tool at all, that's completely up to you. You can think of Mech tools as just a Python script that does some work for you. And if that means making decisions or making multiple LLM calls, yeah, that's completely up to the developer to decide. The tools we have at this point, and you can check that on Mech, on the Mech repo, are focused on using just one LLM. Although some of them use different tools. For example, the actual prediction online tool first uses Google to extract a lot of URLs related to a specific topic, then uses, I think it's, what's the name of this? Well, other library to scrape all those URLs, extract information, and then sends all this information to ChatGPT to try to predict whether an event will happen or not. Yep. Next one.
Okay. From Carlos, do you need to have funds in your wallet in the Gnosis chain if you are performing to request against that blockchain?
Yeah, that's correct. So here I showed a Mech request that went through, went to Gnosis chain. So I need to have some XDAI there. Just a few cents is enough. If you are making this request to the Celo network, for example, you will need some Celo as well. Yeah, you always need some funds on the target chain.
Okay. Now, Alex is asking, has scalability been addressed if Mech call can take up 2 minutes now? I'm talking about a scenario with hundreds, thousands of users.
Yeah, we actually had some issues with scalability lately. At the beginning, there was not a lot of different agents using the Mech tools, but lately, as we saw in the beginning, we have more than 400 at the moment. And this means that, yeah, the Mech is constantly in need to be improved. And as you said, sometimes we find these issues. It could be the case that this issue that we are seeing today with the Mech not delivering could be related to that, or maybe the Mech is under, they are redeploying it or something. But yeah, there's certainly some work to be done sometimes there. At this point, we are serving several hundreds. Most of the time, I think we have like 99% of uptime. But yeah, you will find some of these circumstances like we have today where we can have some requests not being responded or taking too much to be responded. In that case, you could use some timeout and so on. Yeah, there's something that we are working on.
There is a question about updating the documentation because they don't really know many settings in skill.yml, and also,
Well, there will be other sessions focused on agents, as you haven't seen today. Today, we just focus on the smallest piece of code, which is a Mech tool. Here we are now talking about agents. When you say skill.yaml and AI agent YAML, we have someone working on documentation right now. Basically, we need to make some improvements, but because we have a lot of things going on at this point, So I am aware that some of the documentation is a bit outdated. So we are going to definitely fix that.
Ken is asking for demo. For demo, you were using terminal to interact with Mech. In the diagram of Mech request response flow, there's an application interacting with the Mech.
Yeah, sure.
What does? Yeah, go ahead.
Yeah, application can basically mean anything. When I interacted through the terminal, that means the terminal. But if you recall, I am running also a second Mech request here, that I made from this Python script, which is inside the scripts, Mech request. So in this case, this simple Python script is the application. Of course, this could be an agent or even a front end that you say. Yeah, basic application can mean any code or any software that needs to make a request. Can be both front end or back end, both agents, but also just simple scripts. About the recording, that's for you, Carol.
Yeah, this is going to be released. You will receive, everyone will receive a follow-up mail as well with these slides.
Yeah.
Chris is asking what makes people want to use your Mech tools, and
yeah. So yeah, this is something I talked about at the beginning. Mech tools are basically libraries I think this is the best way of thinking. Sometimes you want to implement things yourself, or you don't want to make requests, and that's okay. But there are some other times when basically you don't have the knowledge to implement, for example, a trader strategy, or B, you don't want to pay for OpenAI API and Twitter API and Stability AI API, because that adds a lot of complexity to your application. And for those cases, for those people in this situation, Mechs are a good solution, because basically they abstract away all these implementations, all these strategies, all these LLMs or APIs, and unifies everything in a nice, unique interface. So you can basically use the same request, just changing your prompt to use a different tool, either being an LLM, but also, I don't know, getting some tweets or creating a nice image or running a trading strategy. If that's your case, then the tools for the Mech tools are for you, because it means that there's some code already available off the shelf that you can use on your application. Yeah.
Then Alex is asking about the donations from the white paper. Donation seems to play a big part. How would the rewards be addressed if there are no donations? Yeah, here rewards cannot be guaranteed in any way. So if you build useful code and the community thinks that your code was useful, chances are you are going to get a donation. But nothing here can be guaranteed. So that's why we are running this workshop, so you can start building as fast as you can to experience yourself if the rewards, how they work and how much you would receive and all of that. Let's say it's like experimental phase for you as a developer joining. Now another question. We have these 3 more questions, and then let's okay, Mike wants to ask something. Mike, do you mind if I just finish these questions and then I'll give you the word? And so we have how to change a target chain from
So let me kill this request I did. This is the command I ran before. So here you can see that I specify here Gnosis, but I could change this to Ethereum, and that's it. The only other thing that you need to take into account is that the Mech ID, which in this case is 6, also changes with the chain. And to know which ID you need to use, if you go to the Mech repo, at the very bottom of the README, you have this table here where it says basically for each of the networks where the Mech is deployed, this is the ID: 6 for the Gnosis, 2 for Arbitrum, 2 for the other. Basically 2 for everything with the exception of Gnosis, which is 6. So if you, instead of Gnosis, you are going to make this request to Zillow, you basically need to set this as 2 and then change Ethereum as 0. Same thing goes for the script. Here is where you specify the agent ID. This should be 2 and this should be 0, and that's it. Next one is, where can we find a list summary of the existing Mech tools? Okay, perfect. Yeah, same thing. Go to the Mech repository, which I'm going to share right now. And following the same structure as the Mech tool template, we go to packages, and you can see here that there's a lot of different authors. This one, NaftAI, Nick, Polygraph, Soranis, Valerie. All of these contain different tools. If you go into Valerie, for example, here you go into customs. Remember that customs is the folder that includes all the Mech tools, and you have here native transfer request, OpenAI request, prediction request, prepared transaction, result market. Usually, these have a brief explanation on the component.yaml. If it is not clear what these tools do, you can ask on Discord, and the engineer in charge of working with all this with the Mech and deploying these tools will answer promptly.
The last question is from Peanut. I don't really understand. Yeah.
If there, okay. He means if there is some multi-threading communication between the agents. This is something I cannot answer right now. I would need to check with core engineers. But basically, all the agents run in an asynchronous fashion. So basically, they actually run multi-thread in a multi-thread way, yes. But with regards to messaging, I would need to check. And I think we have one extra from Mike.
Yeah. I wanted to better understand the relationship between a Mech and a Mech tool. Does a Mech builder decide what Mech tools to include in their Mech, or like how does that relationship work? Or is it one-to-one, or is it like one-to-many, or?
All right. So you mean the relationship between the tools and the Mech? Okay. So whoever deploys the Mech, Mech is basically a multi-agent service. Valerie is currently running the most popular Mech service, but other people can run their own. And the service owner is the one that decides which tools are deployed to their Mech and which are not. Basically, we have been accepting a lot of different tools from different contributors, as you can see on this screen here. We have 1, 2, 3, 4, 5 other authors apart from Valerie. And basically, in this case, for this specific Mech that I have been interacting with, Valerie is the one who decides which tools are going to the Mech and are deployed. But yeah, even in the hypothetical case that you want to deploy a tool and it was rejected to the Valerie Mech, no one prevents you from running your own Mech with your own tools. Okay. Is that correct? Or is that does that answer your question?
Yeah. And then I guess I had a general question too. So the examples you're giving are going to talk to LLMs, but is this also the same mechanism where you can build a tool to just get any arbitrary off-chain data and put it on-chain? So I don't know, hitting some other API, some other external API.
Yeah, exactly. So basically, if you need, I don't know, interacting with some API, I myself, I interact a lot with Twitter API. Then you can, for example, create a a Mech tool that makes a call to Twitter API, gets some data, or from a subgraph. There's some tools that get data from subgraphs. That's it. We have been focused a lot on LLMs because of the demand of those tools. But anything that you can code in a Python script can be a tool, basically. If you feel, yeah.
Yeah. So then my next question is so in Twitter's case, you need to provide a Twitter API key. How do you define that configuration then? Because the Mech owner needs to set up that key and stuff like that. How does that get defined?
If if you need like a new tool that requires some API that is not already supported at the Valoris Mech, then we would need to change the configuration of the deployed Mech to include this API key, and therefore your tool could work. That, of course, once again, it's up to the engineers running the Mech to decide. But yeah,
but is that like specified just like in your Mech tool, like as a part of the README or something, or how do you specify that there is additional requirements?
No, I mean, the special this. Okay, yeah. So this goes here when you mean like the dependencies.
Yeah.
Yeah. So
well, in this case, it's like an environment variable that you need to set or something like that, right?
Yeah. Well, I'm not quite sure if you need some specific bars because all that goes through environment variables needs to be set by the service owner, not the Mech tool developer. All that you can, well,
so I think that was the example there. So like if you go back to that code, you specify that OpenAI API key is in the environment, right? So
yeah, but this is something that is already in the environment and set by the service owner, not by the Mech tool developer. Of course, you can do this, but no one guarantees you that this variable will exist. You would need to check with Ardian in this case, for example. Okay, I need a tool that uses this thing. So can you set this environment for me? So there you can then access it this way, basically.
Okay, so it's communication with somebody else on the team that manages the actual Mech.
Yeah, of course. If you deploy your own Mech, then it's up to you. But in this case, it's about communication. Yeah.
Okay.
Yep.
And the last question I had was like, is there anything to stop? So like let's say somebody's running their agent, they see your Mech tool is useful. Is there anything to stop them from just like taking your code and just sticking it into their agent themselves directly without? Yeah.
Gotcha. Well, I mean, you can hypothetically not open source your tool, but yeah, of course, this is how open source works. No one keeps me from porting the Linux kernel and running my own distribution.
Mm-hmm.
I mean, it's about also having some. I mean, no one would trust me in the community if you compare me with Linus Torvalds, right? So basically, it's about that. Of course, I can go clone your tool and mint my own, but the community usually knows who's the one who created the first version of it.
Gotcha. Cool. That was it. Thank you.
Thank you for the questions.
Any other questions? Can we just finish here the session? We are ready.
Oh, sorry. One other question for me.
Go ahead.
How are the dev rewards calculated by? So donation happens. Like, how is that calculated in terms of which tool gets what?
What happens basically is at the end of each period, a period when I say period, I mean like a donation epoch. It lasts by at least 1 month. After 1 month, anyone can trigger the end of the epoch, right? So when someone triggers this and the epoch ends, the protocol calculates all the donations that have been sent to any services on Olas protocol. And basically, let's say that we have X amount of Olas to distribute for this epoch. So if only one donation was made to one specific service, then that service gets all the donation and also the Olas top-up. And this is distributed equally between its components. I mean, well, not exactly equally, because the agent NFTs get one part and the component NFTs get the other part. There's some slightly difference there, but basically, yeah, they are distributed proportionally to how many or how much Ethereum was donated to each of these services. Yeah, exactly. It's what Pino said. You have the formulas on the white paper. There's a almost the same formula for components and for agents with some constant difference, but yeah, it is basically that. Yeah.
Thank you, David, for the amazing session. Thanks everyone for joining. I will send a follow-up with all the materials and resources. Sorry, did anyone raise the hand? Someone, yeah, do you want to say anything before we go? Yes? No. Okay.
All
Okay,
right.
everyone, thank you very much.
All right. Bye, everyone.
Bye, guys.